And we have a result. So it's not very visually understandable what is going on there, but we have a fragments, we have an elements falling down. So what we need to do with those points, this is the result of our simulation. Now we need to take our main fragments and connect them to our points, okay? So how we did this in our test, the RBD test. To do this, we can use transform to pieces or RBD deform pieces. So transform to pieces we can use for our static objects, for our small elements. We don't create a deforming for this, so we can just take the points and connect them with the original one. So how we can do this? Again, we have a points, and in those points we have all attributes we need. Come on, let's update it. And the main attribute we need to use is our constraint type. Oh, come on. I don't know why it's reading the cache, but there is a lot of information, so let's try to find attributes. We need to take our constraint type and say, okay, so if our constraint type is metal, then we apply RBD deform pieces. Okay, if our constraint type is static, we apply a simple transform to pieces. So let's make a split. I think then we can add null object and say that is our RBD out, RBD seam out, just in case we want to connect something to this, and we can make it orange. All right. Oh, sorry. Now let's find here. So if our constraint type is, underscore is metal, then that should be a points because we work in with points. Okay. So from the first input, let me add another null object. That should be an P metal. So that's our points with the metal objects. So we will apply deformation for this. And from another input, we will have a P static. So we can see that our constraint type is static here. And for those objects, we will apply a transform to pieces. I'll transform to pieces. It's very simple. Note again, we have a geometry to transform and template points. And also we have rest points here. So we can try to use the first one. So here we need to take our other objects. So to grab all our originally other objects from our main fragments here, we need to do the same splitting. We need to use, oh, we can copy this split. Come on. It's loading the RBD configure. So let's take this split and connect it here. So we're gonna have the same, I guess. Oops. That should be a P static, not a P, just a static. Can call F static, so it's fragment. Let me look at that. Am I right or not? Well, actually, you know what? I don't need to use a configure. Sorry, I'm not using configure. Why it's calculating? I don't know. So split, and it's not a. Sorry. The main difference is not a points; it's a primitives. So it now should work. Come on, yeah. Here they are. And let's connect these guys to these guys. So enable this. and it should find our elements. So we have a name. So let's connect this. It should be the old name. Oh, come on. Or what name we have. I just want to understand what we shouldn't use the standard name because we don't create the old name for our other objects. So it should work with this. Oh, sorry. Yeah, the wrong connection. It connect to static. And yeah, when I create a simulation, I forget one thing. I hurry up and I remove the $F. So you need to put this $F back if you want to save the sequence in the frame range. So now you can see that we have the small object which just fly away from the original one position, and this means that it works. So we can go back to frame, let's say 52. Now you can see that we have a destruction in this area. We have a fragments fly away from the explosion. Yeah, it's all works. All right. So before I do this, I just want to look at the one thing. I go to Geometry Spreadsheet. I want to look at the amount of different attributes, because there is a lot of attributes, and I really don't need to. I already see that I have attributes which I want to delete. And the first one from points, I want to delete the curvature, the normal and texture. Oh my God, there's a lot of things. So I need to keep, I don't need the area. I don't need the class, the cluster. Let's save the constraint type because maybe it should work in RBD. Oh, let's keep this thing. Maybe an old name I can remove. Anyway, so this attribute I want to remove 100%. So the old name is empty. It should be empty here. Yeah, it's empty. So we can remove two because again, old name we use just for our deformation, for our main fragments. The number, I don't know, I can remove. Material inside and outside, yeah, they should be here. The small pieces, other. So the RBD name, in fact, we can, okay, let's keep because we will merge those elements together then. All right, so well, we really can old name save here because when we merge those elements together, again, the old name will appear because those elements should have this attribute. So even if it's empty, we can keep it. Okay. So with the transform pieces, now we have our small elements, but we need to now we need to work with a bigger one. So our main fragments, we should connect with our, so that should be F metal. Metal. Okay. Now we need to connect using the RBD deform pieces. Okay, so let me just look at the last thing here. Yeah, we can even age group them if you want to. Anyway, as we remember from our test, if we look at the RBD deform pieces, there are three inputs. The first input is required geometry. Actually, this is our fragments. Let's connect them here. Here we go. The next thing is constraint geometry. In fact, we don't need those at the moment. It should work even without that. And we have the proxy geometry, but we don't have a proxy geometry. We have just a proxy point. It's not exactly geometry. So before we do the merging or do a deformation, what I really want to do, I want to take my transform to pieces and make a transformation like we did for our, let me just set to manual, for our other objects. But I want to use the transform to pieces from the proxies. So if you look here somewhere, yeah, I guess around here, this is our proxy geometry, which we put inside of simulation. So I take this proxy geometry and I use the same split because again, there is and other and all elements. I want to have just the metal type. So let's update it again. I want to look at this. I want to make sure that I have the proper pieces. It should be a small pieces, but just geometry. So I will do the same which I show you inside of the RBD seam, because I have the points imported. And then come on, update, man. We take a points, and then using the transformed pieces, I apply my geometry. Yeah, this is my geometry, and I apply this geometry to the metal. Oh, sorry, I reconnect the wrong thing here. Da-da-dum, da-da-dum. Here you go. Okay, let's do this a little bit more clear for understanding. So this is our proxy geo, and this is our other geo. So we need to understand where is geometry, and now I can use this proxy geometry to connect as a proxy geometry for the deformation. All right, and let's look what, okay, so with proxy geo, it's very important also to understand what attribute I will use for getting these elements. So here I use a name, but for RBD transform to pieces, I should use the old name attribute. So let's enable that. I'm in manual mode. So match proxy by attribute, and I need to set which attribute I want to use. And in my case, it should be the old name attribute, because we need to have the same name, exactly the same name. And the rest frame. The rest frame in our case is frame 23. The cluster attribute, we don't have a cluster attribute, so we can set the old name also. And I'm gonna keep, maybe increase the radius, maybe like to 1, and I keep all those elements, all those parameters by default. So now I think I need to save this file, and let's update it. Let's update and see what do we have. Deformation can take some time, so I'll make a pause and then we'll see a result. And after the 7 minutes, yeah, it takes some time for a calculation, just 7 minutes for deforming this stuff, we have a result. And what I see from this result is still, you can see, yeah, something interesting with this guy, sorry. Just again, all what we did on this training, we did from scratch, and the result can be different. And you can see that, oh God, it's not exactly what I want to have. So, sorry, I didn't expect this result. All right, I will do some tweaking. I think that I'm gonna change the strength for the side explosions. I make it weaker, and now I can see that it's not enough strength to break constraints on the side and push those elements. So I definitely need to make it bigger. So I still can't create a preview because I need to save this on the cache file. But before I do, I will reseam this situation again. I will change the strength for my last explosion, and maybe create even bigger explosion under the gun, under this gun. So anyway, what we will do next, what is your task? Your task in training is not just do exactly the same what I did. You can tweak, you can manage your explosion, you can put your points anywhere, under the tower, under those guns, in any place you want, and make your own simulation, your own explosion. Also, what I want to do, I'm going to show you how to save the cache file. Also, in many cases with destruction, such a complex object, complicated object, we need to tweak some elements, because in many cases, I don't like how this fragment is falling, I don't like the spinning, it's spinning too fast, or I don't like this or this or this or all of these guys. But what is most important is the understanding in which stage we need to fix this. In many cases, you're saying, okay, let's fix this right now. But I have a big experience creating explosions with the geometry, with the destructions. And like in real world, the destruction is the result of an explosion. But when we recreate this on a CG, we have a different order. We create destruction first and then create explosion. And it's very bad when you have a nice explosion, but you can see that destruction is not much. It's slower than explosion, or it's looking like it's a separate things. Something else create destruction and explosion just somewhere in the background. And that's why if I want to tweak my destruction, like a small details, okay, maybe the strength of the explosion, something like this. Before I do this, I want to create an explosion, and then I can say, okay, I want to remove this fragment, but I can't see it because of the explosion. This fragment is about explosion or inside of explosion, or this is a very big fragment. I don't like how it's looking, but when I create explosion, I put this element into explosion simulation like a colliding object, and it's creating a nice smoke trail or fire trail. So we can see the interaction between explosion and geometry, and it's looking good. All right, but I want to remove this on the destruction stage. So yeah, it's a little bit heavy if you go from destruction stage to explosion and then you back to destruction if you want to fix something. Yeah, if you have a very big, very small deadlines, if you need to make the simulation like till tomorrow, yeah, you definitely want to do this now and then I go to explosion, and that's fine. But in our case, what I want to do, I want to save the simulation after I tweak some strengths for the explosion, and I will show you what tweaking I will do with this, and we will create on a week 4 the main core explosion. And after that we can back here and say, okay, let's tweak this, let's remove this fragment, or maybe decrease the spinning, or break this fragment into parts, or make a custom or manual bending. Sometimes it's very useful, especially if you work with metal. Just a few things you can manually, using the bend node, correct, create nice deformation. That's it. So what we do right now, let's merge those elements together. So we have the RBD deform pieces, and go to merge, and yes, nice thing is gone. Okay, so we're gonna merge those elements together, the other geo and RBD deform pieces. We're gonna merge those. But before I do this, I want to make a few things. The first thing is, again, attribute delete. I want to look at the amount of attributes I have from my RBD deform pieces and make sure that I don't have any unuseful attributes from there. So I can keep the material shop. I don't need the area. I don't need the class. I don't need the cluster. I can leave the old name, the RBD name, the name icon type. Even, I don't know, I don't need a name, I guess. I don't need a name, just a null name, because I don't have small fragments anymore, just a big one. Remove the curvature, can keep a rest if I want to, if I need this. Bar map, I don't know, can remove it. Okay, keep, I don't know. And another thing I want to do is add a normal. So with the normals, I want to cusp the angle like 20 to make my normals correct. Because sometimes with deformation, the normals can be weird, and it's not visually very... it's not easy to find and see it visually in viewport, but in the render stage it can cause some problems. All right, and then merge those guys here. And yeah, and last one thing, it's the velocity. If you look at this geometry, oh, come on, where you are? You don't want to update. I just want to wait again, such a long, big time. But I want to correct my velocities. I want to have velocity, and why I need to do this? Because for rendering, if you want to render out with the velocity blur, you need to have velocities. Also, if you want to put the geometry inside of the voxel simulation, you also need to have a velocity field to have a proper collisions. So what I can do is add the trail sub, and the trail sub can compute velocity for me. Very easy. So just choose compute velocity. We can leave this by default and use again the central difference or forward difference, maybe forward difference, because I'm using nuke forward. So sometimes when in compositing stage, sometimes in rendering, for some elements I can enable motion blur, for some elements I can disable this and add the same motion blur on a compositing software. So you should have the same approximation in both softwares, because it's will look a little bit weird if on your real velocity render you will have one, let's say a forward, and on nuke you will use the backward. It won't match because it will move some elements, some pixels in the velocity direction. So we merge those elements and we need to save this. I don't want to update for now. I want to save the cache, but before I do this, before I will save the cache, I want to change my explosion strengths, as I said, for my side explosion. So ship render, that's how we can call it. $S$F, load from disk, and begin from frame 23, like this. Okay. All right, so another null object. So that's gonna be my RBD out. Make it black. All right, and save the file. Save this file, and let's make it more better here. It's an explosion, and it's very bright, in my opinion. Yeah, something like this. Explosion deformation. We can even select this and say that it's like main sim, and make it green. When you have a very big network, sometimes it's very hard to find the proper node, but now you can just see that we have it here. All right, so that's it for this week, and in the next week we're going to talk about the explosion and tweaking some elements. So see you soon.